Imagine looking up at the night sky and seeing an asteroid hurtling toward Earth. It's a scenario long confined to science fiction, yet today it poses a real question. What would we do? Enter NASA's DART mission, a groundbreaking effort to protect our planet from potential asteroid threats. Welcome to humanity's first planetary defense test. In this video, we'll explore how NASA intentionally crashed a spacecraft into an asteroid to alter its course. This is more than a test. It's a proactive step towards safeguarding our future. The mission targets Dimorphos, a small moonlet orbiting the larger asteroid Didymos. By changing Dimorphos's orbit, NASA hopes to demonstrate our ability to prevent catastrophic impacts. We'll uncover the science and strategy behind DART's kinetic impactor, the mission's execution, and the implications of its success. Join us as we explore how the DART mission marks a new era in planetary defense, paving the way for future strategies to protect Earth from celestial threats. What if an asteroid was heading toward Earth? Now we have an answer. Welcome to the groundbreaking world of space exploration, where reality meets science fiction. Today, we embark on a journey with NASA's pioneering mission, DART, the Double Asteroid Redirection Test. Imagine this, a spacecraft launched with a singular bold purpose to deliberately collide with an asteroid. But why, you ask? The answer lies in safeguarding our planet. DART's target is Dimorphos, a small moonlet orbiting the larger asteroid Didymos. This celestial duo provides the perfect stage for our experiment. The mission is simple, yet ambitious: to alter the orbit of Dimorphos. By doing so, we aim to demonstrate humanity's ability to defend Earth from potential asteroid threats. This isn't just a test, it's a testament to human ingenuity and foresight. The idea is to nudge the asteroid onto a new path, using the sheer force of kinetic impact. This is planetary defense in action, a proactive step towards protecting our future. Join us as we delve deeper into the science behind this mission. We will explore how DART utilizes advanced technology and why this particular system was chosen. Through this mission, we are not only learning about our capabilities, but also paving the way for future endeavors in space defense. Stay with us as we unravel the mysteries and marvels of DART's journey. From launch to impact and beyond, each phase is a leap forward in our understanding and readiness against cosmic challenges. As we transition into the next segment, let's ponder, how far are we willing to go to ensure our planet's safety? The story of DART is just beginning, and the implications of its success reach far beyond our current horizon. The DART mission uses a kinetic impactor. But what does that mean? Imagine a spacecraft deliberately crashing into an asteroid. This is the core principle of the kinetic impactor concept. It's a bold, yet ingeniously simple idea. The objective is to change an asteroid's orbit by directly impacting it at high velocity, demonstrating humanity's capability. The target of this mission is Dimorphos, a moonlet orbiting the larger asteroid Didymos. Why choose a binary system, you might ask? Observing changes in the orbit of a smaller body around a larger one. It allows scientists to determine the impact's effectiveness with greater precision. This mission is not just about crashing into space rocks. It's about testing and validating our ability to protect Earth from potential asteroid collisions. The scientific principles behind altering an asteroid's trajectory are rooted in Newtonian physics, action and reaction at their most fundamental. By impacting Dimorphos, we aim to slightly nudge its path, providing invaluable data for future planetary defense strategies. As we delve deeper into the science, consider the implications of this pioneering mission. It's not just a test, it's a statement, a declaration that we are prepared to defend our home. Stay with us as we journey through the mission's timeline, exploring the intricacies of its execution. Next, we'll trace DART's incredible 11 million kilometer journey from launch to impact. DART embarked on an 11 million kilometer journey, a voyage not just across space, but into the annals of human achievement. It was a mission meticulously planned and executed to test our ability to protect Earth from potential cosmic threats. The spacecraft lifted off, leaving Earth's comforting embrace, and set course for Dimorphos, a small moonlet orbiting the larger asteroid Didymos. This was no ordinary trip. It was a pioneering expedition into the realm of planetary defense. Over several months, DART traversed the vastness of space, propelled by the hopes of scientists and engineers who dreamt of safeguarding our planet. As DART approached its target, anticipation grew. The onboard Draco camera captured stunning images, not just for posterity, but to guide the spacecraft in its final moments. Through Draco's lens, the world watched as DART hurtled towards Dimorphos at incredible speed. The moment of impact was a testament to human ingenuity and perseverance. Back on Earth, NASA's mission control was alive with excitement. Screens flickered with live data as the team monitored every second leading up to the collision. Cheers erupted as confirmation of impact was received. It was a moment that echoed across the globe, a milestone in our quest to understand and mitigate the dangers posed by asteroids. This mission was about more than just hitting a target in space. It was a demonstration of our capability to alter the course of a celestial object. The implications of DART's success reverberate throughout the scientific community, marking a pivotal step in our ability to defend our planet. As we continue to explore the cosmos, missions like DART remind us of our responsibility to protect Earth from external threats. They serve as a beacon of hope and a challenge to remain vigilant and prepared. In our next segment, we will delve into the results of this groundbreaking mission and explore how DART's impact has altered Dimorphos' orbit. Join us as we uncover the data collected from telescopes around the world and look ahead to future missions that promise to build on DART's legacy. In a groundbreaking achievement, the DART mission has changed the orbit of Dimorphos by a remarkable 32 minutes. This monumental success marks a significant milestone in our quest to defend Earth from potential asteroid threats. By redirecting the path of a celestial object for the first time, we have demonstrated humanity's ability to proactively safeguard our planet. The impact, captured by NASA's Draco camera, was a triumph not just for the mission team, but for global collaboration in space exploration. Telescopes around the world contributed valuable data, confirming the orbit change and allowing scientists to analyze the aftermath in unprecedented detail. But this is just the beginning. The European Space Agency's Hera mission is set to follow up, providing further insights into the effects of the impact. Hera will offer a closer examination of Dimorphos and Didymos, enhancing our understanding of kinetic impactor strategies and their potential applications in planetary defense. This success story has captivated educators, students, and space enthusiasts alike, showing that with ingenuity and international cooperation, we can meet the challenges of the future. It's an inspiring example of how science and technology can unite us in a common cause to protect our world. As we continue to explore the cosmos, missions like DART remind us of the vast possibilities that lie beyond our atmosphere. Looking forward, the knowledge gained from DART will be crucial as we prepare for future missions targeting near-Earth objects. As the DART mission transitions to its next phase with Hera, we stand at the cusp of a new era in space exploration. This successful test is not just a victory for science, but a testament to human resilience and ingenuity. Join us in this journey as we continue to push boundaries and redefine what is possible in planetary defense. With each step forward, we strengthen our ability to protect our planet and ensure a safer future for generations to come. Stay with us as we delve into why this mission matters so profoundly in shaping our approach to planetary defense. In a monumental leap for humanity, the DART mission has achieved something unprecedented, altering the path of a celestial object. This isn't just a scientific triumph, it's a pivotal step in our journey toward planetary defense. Imagine, for the first time, humans have directly changed the course of an asteroid, paving the way for future strategies to protect our planet. The DART mission has set a new benchmark in space exploration and defense. By successfully shifting Dimorphos' orbit, we've demonstrated our capability to influence cosmic bodies, marking a significant advancement in safeguarding Earth from potential asteroid threats. This success is not just about technology, it's about the future of human survival. By redirecting an asteroid, we've proven that proactive measures can be taken against possible dangers from space. It's a testament to human ingenuity and determination to protect our home planet. Moreover, the implications of this mission extend far beyond its immediate success. It sets the stage for future endeavors in planetary defense, inspiring upcoming missions like ESA's Hera and further research into near-Earth objects. With these advancements, we're not just reacting to threats, we're preparing for them. The DART mission's success is a beacon of hope and progress, highlighting humanity's relentless pursuit of knowledge and safety. As we look to the future, this achievement reminds us that with innovation and collaboration, we can overcome challenges that once seemed insurmountable. As we move forward, let us reflect on this momentous accomplishment and consider the possibilities it opens for our continued efforts to safeguard Earth. What other celestial challenges might we face, and how can we prepare? The answers may lie in the very stars we've begun to navigate and influence. Next, we explore the potential threats that lie ahead and how humanity is gearing up to face them head-on. As we look to the stars, the success of NASA's DART mission raises a pressing question. What lies ahead in our quest to shield Earth from potential celestial threats? With the orbit of Dimorphos successfully altered, our attention turns to near-Earth objects, or NEOs, those cosmic neighbors that silently drift through our solar system. These silent wanderers hold both fascination and potential peril. To prepare for future asteroid threats, humanity must continue to innovate and advance our planetary defense strategies. This is where upcoming missions like Hera and NEO come into play. The European Space Agency's Hera mission will follow in DART's footsteps, providing crucial insights and data on the aftermath of the DART impact. By studying the changes in Dimorphos up close, Hera will enhance our understanding of kinetic impact effects, refining our methods for future interventions. Meanwhile, NEO, another mission on the horizon, aims to detect and monitor NEOs that could pose a threat to our planet. With its advanced observational technology, NEO will serve as an early warning system, keeping a vigilant eye on space objects that might cross paths with Earth. In this era of rapid technological advancement, preparedness is paramount. Each mission adds a layer of readiness, arming us with the tools to confront potential threats head-on. The collaboration between nations and space agencies underscores a shared commitment to safeguard our planet. As we embark on these future missions, we remain steadfast in our dedication to planetary defense. With DART's success as our springboard, we ask, what will be our next move in defending Earth from asteroids? Join us as we continue this vital journey, exploring the cosmos and preparing for whatever challenges lie ahead. As we stand on the precipice of our technological achievements, we must pause and reflect on the real threat asteroids pose to our planet. The DART mission has demonstrated humanity's capacity to redirect a celestial object, marking an unprecedented step in planetary defense. But this success is just the beginning. It compels us to ask ourselves, are we truly prepared for the real threat when it comes? Can we harness this technology effectively in the face of a future crisis? Our readiness depends not only on technological advancements, but on our collective will to act. So, as you ponder these questions, consider the responsibility that lies with each of us to support and advance these initiatives. For it is our vigilance and preparedness today that will safeguard our world tomorrow. As we look to the stars and dream of possibilities, let us not forget the importance of protecting our home. If the real threat comes, will we be ready? Your thoughts and actions could shape the future of planetary defense, ensuring that Earth remains a sanctuary in the vast cosmic arena. Let's reflect, prepare, and unite in safeguarding our shared home from potential cosmic threats.